Hello, my name is Travis Phillips. I'm a senior security consultant for Secure Ideas. Today we're on the Professionally Evil GitHub page, and I've added a repo for LD rand hijack or LD preload rand hijack example. It's a example that we're going to go ahead and cover today. This page has a little bit of a README here that's going to explain, basically how to make it and the general use case for it and how it's used, etc. But we're going to cut to the chase here. There's a few files that are here. There is the make file, which this is the file that just simply allowed to use make to build this project because it was written in C. And then there's the source folder, which has our source files. We have guessinggame.c and randhijack.c. Guessinggame.c is the actual main game. So ultimately, the target here is this game, and then we're going to use LD preload with a shared library that we're going to create. And we're going to use this to hijack a function called rand from libc. This game depends on that function for the generation of random numbers, and we're going to hijack it and make it return a static value. So just to kind of give you a little bit of a gist of what the code's doing here, the interesting part is going to be in this main function. This is what's kicked off when the program is started. We've got some initialization of the variables, which is pretty straightforward. There's a variable for storing the random number and a variable for storing the user's guess. And then we have a little print statement here that's to print a banner out. And then there is this little section comes next where we're going to use printf to prompt the user for a number between 0 to 31337, which is a pretty large range to be making a guess into. But we're going to use scanf to read that in, and then we're going to just make sure that it's not bigger than the range that we're trying to guess. And if it is, then we'll just error out and return 1, which is kind of the failure code for this application to be returning. If everything went well here, then that meant that we were able to read the user's guess, and we're going to go ahead and keep trying to move forward, which brings us to srand. This is not the function that we're going to be hijacking. This is a function that is used to seed the random number generator. For that, we're going to use the value of time, which would be the current time that this is kicked off. It's not exactly a secure method for seeding the random number generator, but it's fine for the sake of the game and this example. So we're going to proceed with that. Next thing that we're going to do is we're going to get and assign the random number. This is where we're using rand, and this is the function that we're going to hijack. This is going to be a function that would generate a random number and return it to you based on how the random number generator was seeded. Next thing that we're going to do is do this little %, which means that we're going to mod by this number. So 31338. Our range was from 31337 being the top of the range. We just basically add 1 to it. This little operator here, mod, if you're not familiar with it, it's going to basically take this number and divide it by this number, and it's going to use the remainder. So that's kind of a lazy way to ensure that it's within range of that 0 to 31337. Because if it was actually equal to the 31338 with the division, then it would actually just cycle back to 0. So that kind of keeps us in our range check. You can actually build a debug version of this binary using the make file. I've set up a build target that would let you build a debug build. And if you had that enabled, then it's just going to print out the variables and let you know what their values are. That can be kind of good to be able to see how random's changing or not changing depending on where you are in this attack. And then finally, we come down here to this if statement where we have a check to see if the user's guess equals the random number that we generated. If so, we just print a little banner, and we're going to return 0, which is the success. Or we're going to make it down here, at which point we're going to print a message telling the user that they lost and return -1. So that's the gist of that. We have the random hijack C file, which is a very short file. This is the extent of the code here. But this int ran void is actually matching what the header file matches for this. Generally, you want to make that match the best you can. And then that would allow you to make the function hijack occur. So in this case, we are hijacking it. And we are going to, instead of having it return a random number, it's going to just return 42 as a static value. It will always return 42 anytime you request a random integer from this. It's going to just return that value. So it's going to be a static 42. So now that we've covered that, we're going to head back here to the actual top level of the repo. And we're going to go ahead and clone this repo down. So we're going to click on this little code button, copy this URL, and fire up our shell. And then we're going to do git clone and paste that URL. And hit enter. It'll clone pretty quickly. It's a pretty light repo. So now we can change into it. So it would have created a directory that matched the name of the repo. And now that we're in it, we can do an ls-l. And we can see that there's a few files. There's the license and readme, which are just pretty standard GitHub files. There is the make file, which is what allows you to build things with make. And in that, I actually put a target, which is help, which allows you to see the targets that you can build. By default, it goes for all, which just builds the game, builds the hijack library, and that's all good and well. So we'll actually just use that one, do make. And you can see there's two little commands here for GCC that just built our game as well as our hijack library. And we should be able to see those now. So yes, we do have our guessing game and random_hijack.so. So we're going to go ahead and just give this a shot and play our guessing game. And here's our prompt for the number. So we're going to say 42. And we lost. Try that again. And we lost again. So this time what I'm going to do is I'm going to use make and I'm going to let it build the debug version of the game. So that would enable us to see what the actual random number was. And as we can see, we're getting a pretty good range of numbers here. The chances that we would successfully be able to guess this number, not very likely. That is not without cheating a little bit here. And that's what the LD preload is going to allow us to do. So we can use LD preload to hijack the function, and then at that point, do whatever we want. So it's going to be our code execution. We decided we're just going to return a static 42, which is going to make this game really easy. So what we're going to do here first, before we get into that, is I also have the man page up here, which is for the ld.so man page, which is where you can find information about the LD preload environmental variable that is read. It allows you to give it a list of user-specified ELF shared objects to be loaded before all others. And then this particular line is the one that is the most interesting. This feature can be used to selectively override functions and other shared objects, which is what we're planning on doing here. But either way, that's a pretty handy little bit of functionality there, and it's great that that's just perfectly outlined there. But there's a lot of uses that we can actually do with that. So we're going to go ahead and try that out. Now, generally with environmental variables, I know a lot of people are fans of doing like export and then the name of the variable equals and then whatever the value is. I wouldn't set it to your exported environment. You can actually do an environmental variable as a command, or like as a part of your command. So we're just going to put LD preload equals, and then you're going to want to put the /. It's needed. If you don't provide the /, then what it's going to do is it's going to check the lib path and see if it can find it. If it can't, then it's going to fail out. But with the /, then it understands that it is in the current directory. And now we're going to try to do our guessing game again, which I need to have a guess / on that as well. So now our library should be loaded in and be hijacking that random function. So now, since we know that that's going to return 42, we should be able to guess 42 and win, which we did. And it's going to do that every time that we play this game. In fact, we're going to guess 41 on this one, so we can lose, but you can see it still got 42. So this will work as long as we're doing that LD preload. Once we stop doing the LD preload, we're back to normal and business as usual. We're going to keep getting random numbers that we probably can't guess. So, and reload the LD preload, and again, we're back in control of the random number generation, and we will win every single round. So I hope this kind of gave you guys a visual representation of how this works a little bit, and we hope that this kind of helps you understand it a little bit better. There will be a blog that will go along with this that is complimentary at blog.shakirideas.com. And of course, the Get page did have the Mant page that kind of, or the README rather, that kind of gave you a little bit more information here. But either way, I hope you enjoyed today's video, and thank you for watching. Bye.